Today's lesson is day 1 of 7.4. Evaluate logarithms. Take a look at the warm-up. And even though we have not learned anything about logarithms or logs, look at each of these statements and see what you think would be true. Look at the numbers and see if you could come up with some equation using those numbers that would be a true statement. Hopefully you'll recognize in the first statement that 2 to the third power is equal to 8. In the second statement, 2 to the fifth power is 32. 3 squared is 9, and 5 squared is 25. So it's letting you know that logarithms basically are a calculation of an exponent. Let's look at a few more. See if you can fill in the blanks on these problems. In the first one, you're really thinking 2 to what exponent is equal to 16? In the second one, you're thinking 5 to the third power is equal to what? In the last one, you're looking at something raised to the fourth power has to equal 81. Before we get to our formal definition of logarithm, you know that 2 squared is 4 and 2 cubed is 8, but 2 to what exponent is 6? That is something that a logarithm would help us calculate. It would help us calculate one of those logarithms that isn't a nice, pretty integer. So we can say that we're going to define x by using a logarithm. And we would say that x can be calculated by taking log base 2 of 6, meaning 2 to the exponent of x is equal to 6. So here's your formal definition. I think the most important part of this definition is what I've put in the yellow box. Notice the abbreviation, the IFF. You remember that from your geometry class, meaning if and only if. That's telling us that this statement in the yellow box is true when you read it forwards and when you read it backwards. It's saying that log base b of y equal to x is true when b to the x is equal to y. And if we read it the other way, we'd say if we have the statement b to the x is equal to y, that would mean that log base b of y is equal to x. Let's look at the beginning part of the definition. Please note that b and y will always have to be positive when you're calculating a logarithm. Doesn't mean that x has to be positive. X sometimes will be negative, but b and y will always be positive. And they've also told us that b can't equal 1. Look at this part of the definition. If b is 1, 1 to any exponent is always equal to 1. So it just wouldn't work to calculate a log, because the exponent could be anything, because 1 to the 5th power is 1, 1 to the 20th power is 1, 1 to the 468th power is 1. So b cannot be 1. So this is the most important statement we're going to have in this lesson, recognizing that when you calculate a log, you're calculating an exponent. Log base b, and that b is subscripted, which when it's written in exponential notation, the b is the base. Let's look at a few more examples. So as you try to evaluate each of these problems, these are all doable without a calculator. Be careful, don't pick up your calculator yet and hit that log button. That's not a log button that's going to work in these problems, and I'll show you why it will be a special scenario later on. But the mindset you should have as you look at line A is that 2 to some exponent should be equal to 16. Each of these problems you're thinking, what is the exponent? When you look at B, 10 to what exponent is equal to 1? Part C, 9 to an exponent is equal to 9. And D, a fraction to an exponent is equal to 25. Well, the top one's pretty easy. Kind of repeats from something we saw in the warm-up. You're going to have 2 to the 4th power. But the part B, what to an exponent is equal to 1? Well, that's just your zero exponent property. anything to the 0 power is always equal to 1. Part C. When you take something to an exponent and it equals itself, your exponent must have been 1. So C, log base b of 9, is equal to 1. I put a yellow box around those two because those will end up being some properties that we'll just want to remember as shortcuts. But before we move on, let's look at part D. When you have a fraction, log base 1/5 of 25, you're trying to think a fraction to some kind of an exponent has to equal an integer. That is a big tip-off that you're thinking of a negative exponent. So you should look back and refresh your memory on the negative exponent property. That would say b to the negative n is equal to 1 over b to the positive n. Or more specifically, the property that says if you have a fraction to a negative exponent, you flip that fraction upside down, thus making it 5 over 1, and your exponent becomes positive 2. So when you have 5 over 1 squared, that does indeed equal 25. Now to our shortcuts, if you will. Please note, anytime you have the logarithm of 1, in this case log base b of 1, that will always equal 0. Why? Because of the 0 exponent property. B to the 0 exponent will always equal 1. Next property. Note that if you're taking log base b of b, log base b of b, the base and what you're taking the log of are the exact same number, that will always equal 1. That's because b to the first power is always just equal to b. So these two items are good to know as shortcuts. You shouldn't have to go through the process of thinking, gosh, what to the 0, something to the 0 power is always equal to what? You should just know that 0 exponent property. As with b to the first power always being b. These two items are just nice time savers for you. Let's look at a couple more examples. Now with these logs, again, not a calculator activity. You are thinking 3 to what exponent is 81? Part C, 1/4 to what exponent is equal to 256? Again, another fraction raised to an exponent. You'll be thinking of a negative exponent here. In part B, 2 to an exponent is 64. So think about each of these for a minute and see if you can come up with them. Let's move on to the answers. 3 to the 4th is 81. 1/4 to the negative 4th is 256. And 2 to the 6th power is 64. Now there are two special logarithms. Let's take a look at those. Log base 10 is used very frequently, and in this case, it's very common. So you will not even need to write the base of 10. If you see a log of x and there's no subscripted number, you should know automatically that they intended for that to be a log base 10, thus the common log. When you have a log base e, remember that's Euler's number, log base e of x, you're finding the log a natural log. E was that natural base, so you're looking at log base e of x. And that is calculated, or that the shortcut for that is taking the natural log of x, and we'll just abbreviate it ln of x. When you look at your calculator, you will see that you have a log button. That's for the common log, log base 10. It doesn't work for any other log base, only log base 10. And below it you have the natural log button, ln. So get used to where those buttons are and try out these couple problems just to make sure that you found the right place on your calculator. So as you punch each of these in, please check here to see if you're coming up with these answers with your calculator. So all of these examples you've seen are just like what's on your homework assignment. So today's homework assignment, worksheet 7.4, questions number 1 through 18.